said something. All right, so since the variables are just x to the first power and y to the first power, these make lines. We talked about this last class. These are linear. What we are reviewing and what we're going to do today is have inequalities rather than equal signs. So the first 4 questions are just review with lines, but that's not actually what the lesson is about. But I feel like if we review with lines, it'll make the lesson go a lot easier. Okay, so the first thing that we want to do is figure out how to graph these, and there are multiple ways of graphing them, but most of you know y equals mx plus b. You ever heard of that? Ever heard of that? Okay. So y equals mx plus b would be the form that most of you were taught and remember. Y equals mx plus b is this current equation in that form. Yeah. So what do we need to do to make it into that form? Okay, so we're going to subtract x. When we subtract x, we get negative y less than negative x plus 5. Is this now in the y equals form? No, because of that negative sign in front of the y. So how do I get rid of the negative sign? Ooh, someone remembers. Who is it? Good job. What happens when you divide or multiply with an inequality? What also do you have to do? Switch the inequality sign. Y greater than x minus 5. So that's the equation, that's the inequality that we're going to graph. Y equals mx plus b, we always begin at b. What is the b value in this equation? Negative 5. That is the y-intercept. Which is 0, negative 5. We go to negative 5 on the y-axis and put a point. That is our b value. After we do our b value, then we find our m value. And our m value is what? 1. And that is the rise over run. So I need it as a fraction to graph it. 1 over 1. So from here, I go up 1 over 1, up 1 over 1, up over, up over, up. Or the other way. The next thing that is special about this inequality is when you go to connect those dots, sometimes we connect them and sometimes we don't. When you did this back in the day in Algebra 1, if you had a greater than or a less than, you would have to make it a dashed line. That's because it's not equal to that line. It is either greater than or less than, but not equal to, so you can't actually draw the line. If you have a greater than or equal to or less than or equal to, if the symbol has the line, then you do the solid line. So is this one going to be a dashed line or a solid line? All right, this one's going to be dashed. So when you connect it, make it dashed. It's not equal to it. And there is one more step. It is either greater than or it is less than this line. And there is a trick to know, but I'm not doing tricks because it gets confusing sometimes. So we're just going to test a point. That's what you should have learned a long time ago, to test a point. Now you may pick any point that you want that is not on that line. Any point. Who would like to pick a point? 0, 0? Why'd you pick 0, 0? Because it's easy to plug in, right? If you can pick 0, 0, go for it. If the line goes through 0, 0, you can't pick it. So I'm going to test the point 0, 0. We test that by plugging it into the original equation, which is x minus y less than 5. So we do 0 minus 0 less than 5. So we do 0 less than 5. Is that true or false? If it is true, that means 0, 0 is a solution. And that means that anything on the border, on the side of this border, anything on the side that has 0, 0 is also a solution. So what do? Yeah, we shade it. Do not write the word shade. Why are you laughing? You do that? Somebody did that yesterday. You actually shade it. You don't write the word shade. Oh. You remember ever doing this? Maybe for like a day? No. Way back, a long time ago. No. Well, that's too bad. Alright, so I'm going to give you a couple moments to work on any of the other ones, and we'll go through them. I'm going to pause it. You work on any of the other three. Okay, so number 2, you guys walked around, saw you all starting out correct. You subtracted 2x from both sides. So good job. And we got y is greater than negative 2x plus 10. And from there, we're going to find our b value. Oh, by the way, after you do that, it's already in y equals mx plus b form, so we don't have to do any other manipulating. So our b value is 10. You get 2 options. You could either go off the graph, because this goes up to 7. What's my other option if I don't want to go off the graph? Just change the scale. There's no numbers. So if I change the scale, I need to let anybody looking at my paper know that I've changed the scale. Boom. Now everybody knows that I've changed the scale of the y values. You may do more than that if you want. You can put more numbers in, but you got to put at least one number showing me that you changed the scale. So we're going to 10 to begin. Then from there, our slope is negative 2, which as a fraction, that's negative 2 over 1. Do I have to change my x scale if I change my y scale? I do not have to. It's up to you. If you do want to change your x scale also, then you better put some numbers on the x so that I know you changed your x also, but you do not have to. From here, I go down to over 1. So if I changed my scale, I better go to 1, not over 2. Down to over 1. Down to over 1. Okay. Then we go to connect the lines, and this symbol determines how I connect it. How am I going to connect them? Dashed. If it is not obvious to me when I grade your test, I can't give you credit. So if you need to make big fat dashes, then please do that. I don't want you to lose credit because I couldn't tell from your picture. Make them big fat dashes if you need to. Then after we dash it, then we need to test a point. What point could I test? Has to be a point not on that line. 0, 0 work? So I'm going to test that point. Oop, that one right there. See if it works. In the original question, 2 times 0 plus 0 greater than 10. 0 is greater than 10, right? No, not right. False. So that means when I shade, I do not shade 0, 0. So the other way around. Question? All right, this one here, y is greater than negative 3. This is already in the form of y equals mx plus b. Sort of. What is my b value? Negative 3. It is the constant. It is the number by itself, negative 3. So go to negative 3 and I put a point. Then I have to find my slope. My slope is the value with x, but there is no x. So it's 0. And if I need to write that as rise over run, then I put 0 over 1. And I go to my graph and I go up how much? 0 over 1. Up nothing over 1, and so on. Is this dashed or solid?
Solid.
All right, if it has that line, then I need to connect it. It is a line. We need to test a point. What point can I test? Sure, that works. So I'm going to plug in 0 for y, but I don't really have an x to plug it into, but that's okay. Is 0 greater than or equal to -3? Yeah, so that gets shaded. Yes, Gio?
If the greater than or equal than sign is equal to the y, doesn't that always be shaped up right on the graph?
Yes, but it gets confusing when we don't have lines. So like I said, there is tricks to it, but I don't want to do the tricks because it gets confusing. If you figure it out and it works for you every single time, go for it. So the last one is not in y equals mx plus b form. Did you change it yet?
Yeah.
Take a moment and change it if you haven't done that. I will do it too. If you haven't made it say y equals, take a moment. You could say y equals. Correct. So we're going to subtract 6x to get -3y less than -6x plus 5. And then divide everything by -3. What happens if I divide by negative? Right, this sign switches. If you make that mistake and don't do it possibly, I might have the answer wrong. All right, so then we get 2x, and over here, this is just -5/3, or you could write it as -1 2/3. And that's our b value. So how do I graph -1 2/3? Well, I could just change the scale. I'm not going to, but I could. I'm not going to. I'm just going to go down 1 and then about 2/3. It's approximate. And then from there, we're going to use our slope, which is +2, correct? Did I get it right so far? And that's the same thing as 2 over 1. So when I use my slope of +2, and I'm beginning at a fraction, I'm going to end at a fraction. So I'm going to go up 2 full units, not the lines, but 2 full units. 1, 2, and then over 1. Then 1, 2, over 1. 1, 2, over 1. 1, 2, over 1. We're down 2 left. Down 2 left. You just got to be careful that you're just going up even unit, even amount of units. Exact unit. All right. Dashed or solid? The sign right here says dashed because it does not have the equal to. So it's not equal to. Oh, I'm going to make those dashes so obvious. Everybody knows that it is dashed. And then what should I do? What should I do? Plug in what? What should I plug in? A number that's an order pair not on line. What's not on the line that I could test? Oh, okay, perfect. And they made that easier for you, didn't they? I'll show you one that doesn't go through 0, 0 later. All right, original question. 6 times 0 minus 3 times 0 less than 5, so 0 is less than 5, right? True? Okay. So then we get to shade 0, 0. So that's basically what we're doing today, only we're doing it with quadratics. So they're all parabolas. It's the same steps. So what we're going to do today is we're having a test next week. We're having a test right now scheduled for Monday. And today we are doing this new material, but at the same time we're just reviewing all these things that we've learned about quadratic equations. So we're going to review how to find the y-intercepts. We're going to review how to find the x-intercepts. We're going to review how to factor things. Maybe how to use quadratic formula or complete the square. All those things that are going to be on your test, we are reviewing within this lesson. So I am going to go through a lot of steps, but that's for your review, not necessarily what you have to do for every single question on your homework. Okay? And then you should have plenty of time to do your homework in class also. This core concept in your notes, that just says everything that we just went through. Graph it, dash it if it's less than or greater than, solid if it's less than equal to or greater than equal to, test a point, and then shade. That's what this is just saying here. So if you forget what to do, it is in your notes. All right, so we are going to graph y is less than negative x squared minus 2x minus 1. We have learned multiple ways of graphing this. I'm going to review different ways. You can see there's 4 questions in front of you. I'm going to review different ways for different questions so we can get review with all the different ways we've learned. But when you actually take your test, you can do whatever way works for you. All right? For this one, I'm going to suggest, and for all of these, I'm going to suggest, let's find the y-intercept first. We did that for the linear ones too. B was the y-intercept. We always began at the y-intercept. How do we find the y-intercept? It is if it's in this form. So, but what if it's not in this form? How do we always find the y-intercept? Here's a hint. How do we find the y-intercept? What did I just do? Plug in 0 for x. That's how you find the y-intercept. Plug in 0 for x. So in this form, it is easy. It's just the c value. We'll go ahead to the graph and graph it. What is always really important about parabolas, about the quadratic functions when we graph them? What point is really important? The vertex, that middle point where everything reflects over. So we're going to find the vertex. We've learned how to find the vertex by finding negative b over 2a, the AOS, and plugging it in to find the vertex. That's one way. We've done the vertex by finding the 2 x-intercepts and finding the middle of that, which is the AOS, and then plugging that in. We found the vertex by taking this and using complete the square and putting it into vertex form. That's another way. There's lots of ways we found the vertex. I'm going to make sure I review all those ways in some example. This one I'm going to do vertex form. So we're going to find the vertex next. And this one we're going to do vertex form. But I'll review the other ways. So to put in vertex form, we're going to complete this square. Which will be on your test next week. Complete the square. So to start, you're going to add that 1 to the other side. And then we'll only have the x squared and the x term over here. We also cannot have a number in front of x squared. So we're going to factor out that -1. You have to factor out that -1 before you complete the square. And how do we find what goes in the square? We do the middle term, the 2 divided by 2, and then square it. That goes right there. That number is 1. When you go to fill out the other box, you have to remember that we factored out that -1. So you have to multiply those together before you fill out your other square. So in my other square, I'm putting -1. Okay, on the left side, we've got y plus 1 minus 1, so just y. And then on the right side, we have negative, and then we have to factor x squared plus 2x plus 1. We have to factor it. How does that one factor? X plus 1, good. And that's review of what we've already done in here, so I expect that that should come kind of fast now. And then to finish putting it in vertex form, usually there's something left over with y that we put back over in the other side, but it's 0, so this is vertex form. So reminder, vertex form is y equals a parenthesis x minus h close parenthesis squared plus k. What is our vertex? -1, 0. Yeah. We'll go graph that, -1, 0. So that is the middle of the graph. Drew, I know you can find another point now.
Yeah.
Where is it?
It's near the y-intercept.
Yeah, that mirror the y-intercept. Does it make sense? Should this one be going down? Why?
It's got a negative.
Right, that a value is negative. So my graph is matching what my original equation was showing to begin with. Do we have a stretch on this original equation? That -1 value, is there an actual stretch? Just a reflection. So this equation should be easy to graph. It's just a parent function flipped and translated. So normally we go like out 1, over, or up over 1, out 1, like, or I'm not saying it right, out 1 and then down 1, or out 1, up 1, you know what I'm saying? 1, 1. And then we could go 2 and then what? 4, right. So we go 2 and then 4 and we can get more points. And now we go 3, then 9, but that's off my graph, so I'm not even going to bother. Then, before we connect it, we ask, is this dashed or solid? Dashed. So when you connect it, make it obvious that this is dashed. There. One last step. What do we need to do?
Check it.
Not check it, but test a point. What point could I test for this? Oh, I can. It's not on the parabola, so I can test it. So I put that into the original equation. 0 less than -0 squared minus 2 times 0 minus 1. I just test it up here. It's not good. 0 less than -0 squared minus 2 times 0 minus 1. So 0 less than -1. Is that true? 0 less than -1? No, that's not true. So then I do not shade 0, 0. I shade inside the parabola instead. Okay, I'm gonna pause this, and then there are 3. And I don't know if you're gonna be able to do every single step for every single one of them, but I'm gonna give you a moment to do what you can. You can try to find vertex form. You can try to find the y-intercept. You can try to find the x-intercepts. We haven't reviewed that today, but that is in our chapter. And if you're afraid to graph it because you're not sure if it's right, ask me questions first. And we will, I promise, go over all of this stuff together too. I'm going to give you some time to try to figure some of this out on your own first. All right, so we have the y-intercept. What do we get for the y-intercept? 0, -8. And that is off my graph. So I have 2 choices. I either go off my graph or I change what I'm counting by. I'm going to change what I'm counting by. There, now everybody knows what I'm counting by. So -8 is here. Then what I'm going to show you next, which some of you did, some of you did not, was how to find the x-intercepts on this one. So I'm going to do the x-intercepts. So if you did not find your x-intercepts, this would be something you write down. When we do the x-intercepts, we make y 0. So in the equation, I have 0 . And when you're solving to find what the x-intercepts are or what the y-intercepts are, you can make it an equal sign. The only time we really need the greater than or less than symbol is if it's dashed or solid and where to shade it. Everything else you can just treat it like it's equal. So I'm going to use an equal sign to find the x-intercepts. I'll look at this and I have a couple options. I could complete the square, which some of you did. I could do quadratic formula because that always works. But I happen to notice this one factors. Fast and easy. So I'm going to factor it. X, a plus and a minus to make me a -8. What multiplies together to give me -8 but adds to give me +2? +4, -2. So then we solve to find our x-intercepts. And we get x is -4, but x is 2. So on my graph, at -4 and at +2, the graph passes through. If I found my x-intercepts first, I can now find the axis of symmetry. It's the middle between the x-intercepts. It's exactly the middle of those x-intercepts. We had done this in chapter 2. The axis of symmetry, when you know your x-intercepts, you add them up and divide by 2. You average them. So my AOS is -1. That means my vertex is -1 comma something. How do we find our vertex? If I know that it starts at -1. How do I find the y value? Yeah, plug in -1 in the original question. So we're going to do -1 squared plus 2 times -1 minus 8. So it's going to give me 1 minus 2 minus 8, -9. -1, -9. Whoops, that's not where -9 is. I can also find a mirror point. And then what do I do next? I gotta connect it. Is it dashed or solid? Solid. That one's solid because it is equal to. So we have a border. We have a border. If you're on your calculator, you should be done with this. I don't see graphs. and just because you don't know what to do yet, do you know how to find the x-intercepts that I just spent 3 minutes going over? So you've already done the x-intercepts for the first one. Okay, from here we're going to test a point. What point can I test not on the parabola? 0, 0. So I get 0 is greater than or equal to -8. Is that true or false? True. So I have to shade 0, 0. That's inside of the parabola, so I shade everything on the inside. So if you guys get this and I'm working too slow for you because I'm recording it, please work ahead. There's a whole another page of notes that we still have to do. If you already have those 3 done. Please don't feel like you have to stay with me because I'm recording all this. That's why I have to do every step. All right, the next one, what do we find first? What do we find first? Y-intercept. 0, 4. Graph it. All right, for this one, I'm going to demonstrate finding the vertex by using -b/2a, which we had done in chapter 2. So I'm reviewing that if you'd like to use that method. To find the vertex, we have to find the AOS first. Ooh, good question. Have you ever seen -b/2a other than using it for the AOS? Have we seen -b/2a anywhere else in this chapter? Do you think that's coincidence? This helps. Remember this discriminant here helps figure out if we have 2 solutions or 1 solution or no solution. And then this part here is the middle. So you take your middle, your AOS, and then you go out this much and out this much. That's the plus that much and minus that much from the middle. It's giving you the parabola. I don't know. It's pretty cool. There we go. All right, so we're going to do -b/2a. -2/2 times -1. So the AOS is x = 1. And then from there, we find our vertex by plugging in 1 to find the y value. So we do -(1 squared plus 2 times 1 plus 4. I've seen a lot of us not doing order of operations correct over here. You do squared first, then negative. You get -1 plus 2 plus 4. 5. So we have the vertex at 1, 5. We have a mirror point. You could do quadratic formula to find the other x-intercepts. I'm not going to do that right now because they're not nice answers. And also, is there a stretch on this one? Is there a stretch? There's not a stretch, so I can just find more points using my parent function. So this is 1, 1. I could go 2, 4. I could go 3, 9. So I could use my parent function to find more points, and you can see that it does not have nice x-intercepts. Did you have your AOS wrong? Yeah. And then dashed or solid? Why? Because not equal to. Perfect. So I'm going to overemphasize the fact that this is dashed. point. I'm gonna go ahead and test 0, 0 because it's not on the parabola. So we get y is greater than 4. Not y, I mean 0 is greater than 4. Is that true? 0 is greater than 4? No, so 0, 0 does not get shaded. That means everything outside of the parabola, the whole outside gets shaded. Okay, last one, you had time to start it. Did we find the y-intercept? Max, did you get the y-intercept? Yeah. Huh? Can you do it real fast? Just plug in 0. Plug in 0 here and here. Negative 1. Good. Oops. Eraser was too big. So 0, negative 1, y-intercept. Did anybody try to do vertex form for this one? Because it's not a fun one. What did we try? What? You did negative b over 2a, and you still got a lovely number, didn't you? So if you do negative b over 2a, you get positive 1 over 2 times 2, which is a 4. 4.25. So then if we're going to do our vertex, we have to plug in 0.25 into the equation. So if you haven't done that yet, take a moment and plug in 0.25 into the equation, and I'll call on somebody to tell me the answer. Well, when you factored out the negative, that changes this sign to negative. Because you're going to take out the negative here and here. So. Why don't you plug it in? You know how to calculate that? Katie, did you plug it in? Yeah. Katie? You can square it. You just plug it in just like that into your calculator. Just plug the whole thing in with 2 parentheses, 0.25. When you plug this in, you guys, if you're, like, I'm not going to do this by hand. When you plug it in, you can type in 2 parentheses, 0.25, close parentheses squared, minus parentheses, 0.25, close parentheses, minus 1. You can just type that straight into your calculator. Straight in. It does the word of operations for you. You type it in, you should have an answer like 30 seconds ago. Emily, you on? I'm sorry. Emily, what'd you get? Negative 1.125. That's what you should get. Negative 1.125. If you did this by fractions, if you put it into fraction form, you get negative 9/8. So then we're going to graph that. So you could have made your scale better to graph it a little easier. I didn't make my scale better. I just left it as is. So I'm just going to approximate 0.25 and then negative 1.25. It's about there. It's just approximate. We need to find more information. Where else can we find information? Ooh, the mirror point. Okay, I better draw this. Oops. It's really hard to do it up here though. Okay, so I got a mirror point. Still not really enough points to have a somewhat accurate graph. How else can I get more points? Ooh, x-intercepts. Let's do that. Means make y 0 and solve it. Does this one factor? Because if it factors, that's easy. If not, quadratic formula. Does this one factor? What can I multiply together to give me -1? Positive 1 and -1? How am I going to get a -1 in the middle? Does that work? If I have a -2x and a positive 1x, does that give me a -1x in the middle? So then I've factored it correctly. What do I do once I factor it? Set them equal to 0. Good. So we have them set equal to 0. We're going to solve each. We have 2 x-intercepts. So we're going to plot those on the graph. -0.5 and +1. Do those seem reasonable where I plotted them with the other points that I have? Is this going to be dashed or solid?
Solid.
What point should I test? So get 0 less than equal to -1. Is that true? No, that is false. That means 0, 0 does not get shaded. I'm going to pause this video before we go on. Okay, we got 2 more kinds. This kind right here has 2 inequalities on the same graph. 2 inequalities, you're going to have 2 shading. So the solution is going to be where the shading overlaps.
He's weird.
Did I really write that? I have no idea why that happened.
Joking during the recording.
Did I really write that though? I could have sworn I wrote that way. Anyway. Okay, I'm just making sure you guys are paying attention. So we're going to graph y equals -x² plus 3. I'm going to do this fast because of time. Y equals -x² plus 3 is already in vertex form, where the vertex is 0, 3. That's already in vertex form. The vertex is 0, 3. And this one opens where? Down. And it is a, there's no stretch, so it is the parent function values, just is this one dash for solid? Dash thing. And then I'll test a point. I'm going to test 0, 0. So I get 0 less than 3. That is true. So I will shade in the middle. Like I said, I'm going to go too fast. We've already spent a lot of time going through all the steps on the other ones. The second one, the y-intercept, is at -3. This one factors, so I can do the x-intercepts. X plus 2, nope, not 2, 3, I mean. And x minus 1, so the x-intercepts are at -3 and +1. That means the vertex is in the middle of those at -2. And when I plug in -2, is that -2? Just kidding, it's -1. I can't read my own graph. Sorry, that -1. And when I plug in -1 into the equation, I plug it in, I get -4, I believe. Makes sense with my graph. And this should be solid. And we'll test a point. I'm going to test 0, 0. I'm going to test it right here. I'm going fast through these, like I said, because we've already done a bunch of those. So 0 greater than or equal to -3, that is true. So I'm going to shade this one. Okay. So where the solution is where the two overlap. So I'm just going to make where the two overlap look a little bit more obvious. Okay. So the part that I highlighted in, that's where the two overlap. The other two shading is not part of the answer. It's only where the two overlap. So you might want to do like your shading, the first two kind of light, and then like shade in dark where the solution is. Okay, and then this next one, again, going through it pretty fast. Y less than or equal to -x squared is the first equation. And I graph that. That's just the parent function flipped down. And it is solid. How do I test a point for this one? How do I test a point for this one? Why am I asking that? Does it just test like a point for every single one of them? This one goes through 0, 0. So we have one that we haven't seen yet. How can I test a point? Well, I can't use 0, 0. How can I test a point? Pick any other point you want. What do you want to pick? 1, 1. 1, 1? 0, 1? 1, 0? Any of those. I'll pick 1, 1. That one sounds fun. So then I have 1 less than or equal to negative parenthesis 1 squared. And order of operations says do the squared first, then do the negative sign because it's outside. So I get -1. Is 1 less than -1? No. So that means I would shade not 1, 1. I would shade inside. For time purposes, I'm just going to do the other one real fast, and so you have it in your notes, but we've already practiced a bunch of these, and I want to get to the last example. So the other one is dashed, and it does get shaded up, so the solution is where they overlap here. As soon as you have that, copied down, we're doing example 3. Yeah. So you can't really write. the solutions are, she's asking like, what would I write for my answer for this? The answer is the picture. The answer is the picture because the answer is every single ordered pair that I just shaded in, which you can't possibly tell me every single ordered pair because there's infinitely many in that shaded portion. So the answer is the picture. So you guys do have to do these graphs, unfortunately. It'll take a while, I know. This last example, there's actually two. One of them's not written on there, so if you want to take this and like draw a line and we'll do the other one next to it, you'll have room. You will have room. There's two examples, but one of them didn't make it on there. So this last one, if you look at the equation, there is only x's, there's no y's. So we're not going to graph this on the xy coordinate plane. We're only going to graph this on an x number line because there's only x's. So this is how we would solve this. It says solve it algebraically. So how do I solve for x when there's a squared in it? How do I solve for x? I could do square roots, but it doesn't work if there's a middle term. So square roots sometimes. What else? Factor. Factor if it will factor. What if it doesn't factor? Quadratic formula or complete the square. This one factors. So we've got x and x. What makes -4 but adds give me -3? -4, +1. So we get x minus 4 equals 0. X plus 1 equals 0. We get 4 or -1. I told you this one is just x's. So we're going to only draw the x number line. And here's a fun fact. You don't have to put 0 in the middle of the number line. Just fun fact. You don't have to if you don't want to. You know, everybody does it. Have to. I could if I want to put 0 over here. You know, if I wanted to. All right, let's go back in the day here. When you did number lines a long time ago, how did you know if you did an open dot or a closed dot? If it's equal to, it's closed dot. So if it's not equal to, open dot. So on my graph, I'm going to put an open at my solutions. And then I have to figure out if I shade in between the dots or on the outside of the dots. And we figure that out by testing a point. What point could we test that is not one of those dots? Well, it's just 1, 0 though. X equals 0. I'm going to write it that way. Because this is only on the x number line, so we just need to test x equals 0 to see if x equals 0 works. So we're going to plug in 0 into the equation. 0 squared minus 3 times 0 minus 4. And is it greater than or less than? So we're going to test that point. Does it work? -4 is less than 0. True. That means I get to shade in between the dots. And we can write a solution for this. To write the solution, it's in between these numbers. So you start with the number -1. You end with the number 4. And you say that x is greater than -1 but less than 4. You put it in one of these things. Have you seen one of these? You have seen one of these before. I asked like you're like if you have. Do you remember it? I don't know. The x is in between the two numbers. That's how you write it. You always write it less than. So we have one more example. That one is not in your notes. You have to copy it down. So the last example is solving x squared plus 4x minus 32 greater than 0 algebraically. So we're going to do the same thing. Will it factor? What makes minus 32 but adds give us 4? Positive 8 minus 4. 8. So we get our two solutions at negative 8 and positive 4 when we solve them. Oh my gosh, that was so not even. I did a really bad job, sorry. I was trying to hurry. Are we going to have open dots or closed dots? Open dots. Oops, why did I just close it? Open dot. Now we test the point. What point can we test? Let's test 0. So we have 0 squared plus 4 times 0 minus 0. I don't know what's happening to my marker right now. Minus 32 greater than 0. So negative 32 is greater than 0, right? Balls. So instead of shading in between, I shade the ends. I shade outside, like that. When you have a solution that looks like this, we have two pieces to the solution. We write that x is less than negative 8, or x is greater than 4. You write or in the middle because the picture looks like oars on a boat. Okay, but you need to write or in the middle, not the other 3-letter A and D word. Just 4. All right. Whew. That was everything for today. When you log in, get your computer. When you log in, your assignment should take a lot less time than our notes today. It should. Because you're not going to have to grab every single one of them. You log in, grab your computer, grab one for the person next to you. Grab your computer. Yeah. Oh, 15.